Hello everyone. Today we are going to analyze this fixed beam. In this beam there are two loads. One point load 9 kN. It is acting at a distance of 2 meter from the point A. Then we have uniformly distributed load 4 kN per meter. It is acting for the whole span. Length of the beam is 6 meter. To find the fixed end moments in the point A and the point B, let us use formulas. If the fixed beam is subjected to uniformly distributed load for the whole span, the formulas to find the fixed end moments are WL square upon 12 and WL square upon 12. Both of the formulas are same, but the moment in the point A will be acting in the anticlockwise direction and the moment in the point B will be acting in the clockwise direction. If the fixed beam is subjected to an eccentric point load W, the formulas to find the fixed end moments are WAB square upon L square and WA square B upon L square. Here also the moment in the point A will be acting in the anticlockwise direction and the moment in the point B will be acting in the clockwise direction. Now using these formulas, let us find the fixed end moments. First, let us take the point load 9 kN. We have just seen the formulas WAB square upon L square and WA square B upon L square. Here W is 9, A is 2 and B is 4, L is 6. Let us apply them in the formulas. Now let us take the uniformly distributed load 4. We have seen the formulas to find the fixed end moments. Both of the formulas are same, WL square upon 12 and WL square upon 12. Here W is 4 and L is 6. When we add these two, we will get 20 kilonewton meter, and when we add these two, we will get 16 kilonewton meter. We know that MA will be acting in the anticlockwise direction and MB will be acting in the clockwise direction. We have calculated the fixed end moments MA and MB. Now we are going to find the vertical reactions RA and RB. First, let us find RA. For that, I am going to take a moment about B. In this case, we are moving towards right hand side. Clockwise will be positive and anticlockwise will be negative. The movement MA is acting in the anticlockwise direction, so that it will be negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 6. So 6 RA. The point load 9 is acting in the anticlockwise direction, so that it will be negative and the distance is 4. The UDL 4 is also acting in the anticlockwise direction, so it is also negative. For the UDL, we have to multiply with the distance and distance by 2. The moment MB is acting in the clockwise direction, so that it will be positive. Finally, for RA, we are getting 18.667 kilonewton. Now, let us apply the rule sigma V is equal to 0 and find RB. RA and RB are acting upwards, so both of them are positive. These two loads are acting downwards, so both of them are negative. With the UDL, we have to multiply the distance. Finally, for RB, we are getting 14.333 kilonewton. Now we are going to draw the shear force diagram. I am going to find the shear force values from the point A and towards the point B. In this case, I have to follow right hand side rule. Upwards will be positive and downwards will be negative. Here you can see the calculations. Here you can see the shear force diagram. Now we are going to draw the bending moment diagram. The bending moment diagram can be drawn in two ways. The easiest method is superposition method. In this method, first we have to convert the fixed beam as a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Now we have to draw the bending moment diagram for this simply supported beam. First, let us find the reaction RA. For that, I am going to take a moment about B. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. RA is acting in the clockwise direction, so that it will be positive and the distance is 6. So 6 RA. The load 9 kN is acting in the anti-clockwise direction, so that it will be negative and the distance is 4. The UDL 4 is acting in the anti-clockwise direction, so it is also negative. For the UDL, we have to multiply with the distance and the distance by 2. Finally, for RA, we are getting 18 kN. Now, let us apply the rule sigma V is equal to 0 and find RB. Now, let us find the bending moment in the point C from the point A. RA is acting in the clockwise direction, so that it will be positive and the distance is 2. The uniformly distributed load is acting in the anti-clockwise direction, so that it will be negative. For the UDL, we have to multiply with the distance and distance by 2. So for the bending moment at C, we will get 28 kN meter. Now we can draw the bending moment diagram. We have uniformly distributed load for the full span, so the diagram will be in the parabolic shape. This diagram is called the free movement diagram, and this diagram is positive. Now let us draw the end moment diagram. For MA we have got 20 and for MB we have got 16. We know that MA was acting in the anti-clockwise direction and MB was acting in the clockwise direction. We have to see the direction of the arrows. Both of the arrows indicates upwards. So the diagram will be coming above this line. Since 20 is bigger than 16, we have to make this line little higher. Then we can combine both of the diagrams so that we will get the bending moment diagram. Where both of the diagrams are combined, we should not mark anything. We just keep the space empty. Wherever they are acting alone, we have to mark with the signs. We have drawn this diagram by superposition method. Alternatively, we can draw the bending moment diagram considering all of the points. But it is up to you. You can either follow the previous method or this method, whichever is easier for you. Here we have to find this ordinate. This is the value of maximum positive bending moment. For that, we have to see the shear force diagram where the bending moment becomes 0. In this point, the shear force becomes 0. In this point, there will be maximum positive bending moment. In that point, let us make a section at a distance of x from the point B. We know that in this section, the shear force is 0. Let us find the shear force from the point B. In this case, we have to follow left-hand side rule. Upwards will be negative and downwards will be positive. RB is acting upwards, so that it will be negative. The uniformly distributed load is acting downwards, so that it will be positive and the distance is x. After the calculation for x, we are getting 3.583 meter. Now let us find the maximum positive bending moment. We are going to find the moment from the point B. In this case, we are following left hand side rule. Clockwise will be negative and anti-clockwise will be positive. This moment is acting in the clockwise direction, so that it will be negative. RB is acting in the anti-clockwise direction, so that it will be positive and the distance is 3.583. The UDL is acting in the clockwise direction, so that it will be negative. For the UDL, we have to multiply with the distance and distance by 2. For the maximum positive bending moment, we are getting 9.68 kilonewton meter. Let us find the bending moment in the point B. In the point B, we have the moment MB, which is acting in the clockwise direction, so that it will be negative. In the similar way, we can find the bending moment under this point load. We will get 9.33 kilonewton meter. To find the bending moment in the point A, we can use right hand side rule. Clockwise will be positive and anticlockwise will be negative. In the point A, we have MA, which is acting in the anticlockwise direction, so that it will be negative. Using the values, we can draw the bending moment diagram. In these 2 points, the bending moment becomes 0. We can find the location of these 2 points, but it is not necessary. Anyway, I am going to find both of the locations. For that, I have to make sections in both of the points. You can see that I have made sections in both of the points at the distance of x from the point A. First, let us find the distance x in this section. For that, we can use the right hand side rule. Using that rule, for x, we are getting 1.23 meter. In the similar way, we can find the value of x in this section. We are getting 4.62 meter. If this distance is 4.62, this distance will be 6 minus 4.62. We will get 1.38 meter. So we have found both of the locations where the bending moment becomes 0. Now we are going to end this session. Thank you for watching this video.